All right, so again, we're going to be talking about arm day today. Now, I know you know some of the stuff already, but we're going to be going over it again, recapping to solidify the information, and then as usual, we will be literally applying because it helps to remember. So when I say arm day, I'm talking about biceps, triceps, front delt, rear delt, lateral delt, okay? Now, if you want to talk about complete arm day, it would be forearm extensor, forearm flexor, bicep, tricep, front delt, rear delt, lateral delt. These are the muscles on your arm. I don't worry about your forearms. Your forearms get a lot of work just picking up weights. There's no reason to do that. What do muscles do? Muscles pull and only pull. Muscles don't push. Muscles pull, just like if I took a rope and I tied it to a box, I could only pull the rope towards myself. I couldn't push it away with the rope. I couldn't move it any other direction except towards myself. So muscles pull. Muscles pull by sliding towards each other, insertion to origin. So there's one point where the muscle connects on a bone, crosses over a joint, it then connects on another bone. Its function is to pull these two bones or two levers together. Very simple, as you know, with the bicep. So with the bicep, this is a replica of my arm. As you know, here's my upper arm bone, my lower arm bones, and my hand. Now, the reason it's important you understand this is the concept of lever magnification, the resistance curve, and what muscles do. So we're going to get into a live demo of this in a second so you can see what I mean when I say lever magnification. But a bicep is bi, means two muscles. One muscle group is up here, attachment. The other one is right next to it. It's a biarticulate muscle. It crosses over this joint as well, about 2 centimeters, right about here from the joint. Its function, only function of the bicep, is to be lifting the forearm up, and as you can see, when I do that, it contracts. The reason I can't go anymore is it's fully contracted, meaning the muscle spires have slid together all the way. They can go no further. It's a fully contracted muscle. If I do this, that is now a different muscle group. Makes sense?
Yeah.
All right, now, this guy is origin. He's got the bicep in his hand. Insertion is down here. Origin can only pull. That's all origin can do. Is pull the insertion up. All the muscle can do is cross the joint and pull levers together. And it can only pull them together in a straight line. Any movement which is outside of that straight line is now a different muscle group. Making sense? Okay. Now, opposite the bicep, you have the tricep. Tricep is on the back. Tri means three muscle groups, but it does the same thing. It basically has one point it connects, one point it connects down here. And it does the opposite of the bicep. So it pulls it down instead of up. So when the bicep is working, the tricep cannot be working, the concept called reciprocal inhibition that you already know of. Now, all of your muscles that are skeletal perform exactly like this bicep. So it's very simple to consider each one of these muscle groups as just being a differently shaped bicep, but doing the same thing. So my forearm flexors go like this, my extensors do the opposite. My bicep lifts it up, my tricep brings it back. My front deltoid, little bicep right here, little bicep, lifts it up frontally, frontal plane. My lateral deltoid, small bicep here, lifts it laterally. And my rear deltoid, back here, does it in the reverse. All right, we know all these things. So for arm day, what that means is you need one perfect movement for each one of those. How do you know if it's a perfect movement? It pulls insertion to origin in a straight line, and it follows the correct resistance curve. The resistance curve is what you're about to demonstrate along with lever magnification. So I got this little guy here. It's just a replica of an arm, so let's just pretend in this case this would be representing the lower half of this model, so the forearm part. The upper arm of this model is going to be you, standing here. So right now, for all intents and purposes, this is an arm bent at this position. The bicep is this cable, which connects really close to the hinge. You're supplying the effort by pulling up with your arms, which will lift the forearm, representing the bicep. Does this make sense? So come on over here. All right, so go ahead. Be careful, it's going to come up pretty quick. So just be careful, pick it up. Okay, bring it down. And just move your foot a little bit over there. Now you already know this. It's a 5-pound ankle weight. You love this thing. Now it feels a lot heavier than 5 pounds when it's on your ankle, doesn't it?
Yes.
Yeah, it feels heavy as hell. All right, well I'm putting this 5 pounds at the end of the forearm now, just like if this forearm was holding a 5-pound dumbbell. It's the same thing. Make sense?
Yeah.
Okay, go ahead and pull it up. Pick it up. There you go. Okay, so what did we notice?
It's a lot heavier.
It's a lot heavier.
Because it's down at the end.
So it's a lot harder to pick up in this position, right?
Yes.
How much more force is required? What do you think?
5 times. It seems like it's like 5 times, maybe two to 3 times.
So I'll tell you how much force. You, without the weight, just picking up the lever, is pretty easy. Doesn't require much effort. With this lever, which is 32 inches long, you're going to be multiplying 32 by 5 pounds. Okay, that's going to give you 160. Then you're going to multiply it again by what's called the force lever. So this. I'm not going to get too much into the physics of that, but long story short, it's 1. So long story short, in order to pick it up in this particular position at the 90-degree position, it's 170 pounds of load you're lifting. Now how about when I take this, how about now?
Yeah.
It's easier, right?
Yeah.
Why is it easier?
It was closer to...
The shorter lever.
Yeah.
So a shorter lever, right? It's easier, right?
Yeah.
Exactly. So exactly. So I just like to make the point. Now, when we exercise, we use all of the levers in our body.
Holy cow, that's crazy.
Stop it. Now, when we exercise, we use all of the levers in our body at the maximum length, targeting one muscle only at a time inside the correct resistance curve. Now, just to finish this long story short, this is beginning at a 90-degree angle with 160 pounds of load. The reason I don't have this set up, so it's like this, and you're standing on a table or something with it hanging down, is because in that position, it would require over 1,000 pounds of force to lift it from here up.
Right.
This is because of mechanical disadvantage. You have a better understanding what that is now, but it would literally be too hard for you to pick it up from that position. It'd be over 1,000 pounds. This is actually the correct position to be doing every muscle, starting it with a lengthened muscle at a full mechanical disadvantage, and ending it with a fully contracted muscle at what's called a mechanical advantage. So did you notice, go ahead, pick it up. Did you notice when it gets to this point here, it suddenly gets a lot easier. The higher it goes, it gets easier. That's because you have a mechanical advantage, because as the lever comes up, it's actually getting closer and closer and closer to you, making it shorter, making it easier. As the muscle contracts, it gets more and more contracted, less space. It's supposed to get weaker, and it's supposed to have a mechanical advantage. So in order to have a perfect movement for these muscle groups, you need to pull insertion to origin in a straight line, have the muscles starting with a mechanical disadvantage and ending with a mechanical advantage, and at the midway point of the movement, it needs to be a 100% active lever. And that's how we train every muscle on your body. Does all make sense?
Yes.
Yay!
Yay!